Okay, pre-cal, this is case 4. And case 4 is simply all of the above. All the other cases are all coming together in this particular problem. So we're going to work through this, and I'm going to do it completely for you. So here we go. We have a repeated quadratic factor. So nothing linear. The first thing we do want to pay attention to is that the degree of the numerator is 1 less than that of the denominator. If the degree of the numerator is greater than that of the denominator, you first have to do long division. I may do another short video just on that if necessary, or maybe hit that in the live class. But to get this set up, so step 1, your setup, because the factor is prime and it is quadratic, this is what's necessary. ax plus b over x squared plus 1 plus cx plus d over x squared plus 1 quantity squared. Remember, whenever we have a repeated factor, every descending power has to have a representative. So we do have 4 unknowns in this situation, which means we're going to have to set up a system of equation with 4 variables. Not terrible, totally doable. We're going to push through. So that's step 1. So step 1, still set up. Step 2, still eliminate the denominator. Eliminate with the LCD. So we're going to do that here. We're going to multiply. Thankfully, this one is not missing anything, but this second fraction is, so we are going to multiply by 1 power of x squared plus 1. So now when we eliminate, which we can now because we have a common denominator all the way across, which means we're comparing like parts. So this allows us to just start simplifying and organizing. So that's what I'm doing next. So this is my right side. Nothing's changed. 2x to the third plus x plus 3. Now I hope you're noticing that we're missing a power of x. We'll put that in just a few minutes as a ghost term with a 0 coefficient. We need to use the distributive property here. So ax times x squared is ax cubed. Ax times 1 plus ax. B times x squared, bx squared, b times 1 plus b, plus cx plus d. So we eliminated the LCD. We're going to go ahead and start getting things moved around and put in order. So x cubed, then we have an x, and an x. I'll give them a double underline. Then we have a constant, and a constant, and a constant, which means the x squared term is missing, just like we know, so we are going to put that in as a ghost term over here. So let me shift to another sheet of paper, and we're going to continue getting this all set up. So first of all, let's go with 2x cubed plus 0x squared plus 1x plus 3. That's our left side. Now let's get everything using the commutative property. Let's change the order on the right hand side. So ax cubed. Okay, so those are done. Now let's go to the x squares. So plus bx squared, that's done. Now the x's, so it's going to be plus ax plus cx, and now the constant terms. So that is plus b and d. So there's our cubic term. Here is our squared term. Here is our x term. And then we have our constants. I'll put them in yellow. So now let's factor. I think that's the best thing to do next. I'm showing every step. So factor out the x squared. Don't really need to do that. There's really only one x squared term, excuse me, that is a 3. Forgot the x, we have a plus c, and then finally b plus d. Now we're ready to set up our system. Our system does have 4 variables, and we're going to have 4 equations, but thankfully some of them are going to simplify and solve really easily. So first of all, 2 is equal to a. B is equal to 0. X, oh, excuse me, not x. We don't need x, we need the coefficient of x. The coefficient of x is 1, so 1 equals a plus c. And then finally, 3 equals b plus d. So right away, let's use these 2 values to try to simplify the other 2. So if a is 2, then 1 equals 2 plus c. So if 1 equals 2 plus c, then c equals negative 1. There's a, there's b, there's c. Right over here, we're able to solve for d. B is equal to 0, so 3 equals 0 plus d. D is equal to 3. So even though this had 4 variables, it did solve very quickly. So let's go back to the first page where we had the expansion set up with our general terms a, b, c, and d. And now let's write the partial fraction decomposition. So we've got ax plus b, so 2x plus 0. You don't have to write the 0, of course, but that's fine if you do. So 2x plus 0 over x squared plus 1 plus cx plus d, so negative 1x plus d, which is 3 over x squared plus 1 quantity squared. And that is the partial fraction decomposition for when you have repetitive quadratic factors in the denominator.